That's a very good point. But the point is, when you take an average, we don't care about whether it's above the mean or below the mean. We just want to look at the distance. Does that make sense? So if you look at here, you've got values above and values below. We don't care about whether it's above average or below average, because you know that on average, 50% is going to be above, 50% is going to be below.
Then the reason you want to know the distance is to analyze.
The reason why we want to know the distance is because we want to control for the measure of spread. Okay? Because if we just say, so let's say, for example, with this hospital example here, we want to look at whether you're a good hospital or a bad hospital. In other words, have you got a really high survival rate or have you got a really low survival rate? Now, using the average and only the average, that's not enough. Are you happy? Because on average, you're going to get 50% which are above average and 50% which are below average. Yeah, we said that, okay? Because the mean literally cuts the data in two, okay? So what you want instead is a way to control for saying, well, actually, how far do you expect to be from the mean?
So 0.8 is our...
Exactly. That's your standard deviation. So your standard deviation is saying, well, actually, you should be within 0.8% of the mean. That's your standard deviation. Okay? If you're outside of that range, so what did I say? It was 97.1% to 98.6%. That basically controls standard deviation each side of the mean. If you're outside of this range, then you can say you're a bad hospital or you're a good hospital. Does that make sense? So the standard deviation basically gives you how far on average do you expect to be away from the mean. And then you can infer whether you're a good hospital or a bad hospital. Does that make sense?
Yeah.
Good. Okay.
Can you say that standard deviation is part of the range, like one of the measurements?
Yes, absolutely. So remember that range, so all of these I'm talking about are measures of spread. Okay, they're all measuring how spread out are your data. How spread out are your data, okay? So we've got one measure of spread, which is the range. It's just simply what is the difference in the extreme values. The highest take away the lowest, okay? Another measure which we have now is the standard deviation. Now, are you happy the standard deviation gives you more information than just the range? The range just tells you how spread out your data is overall. Whereas the standard deviation tells you how far on average do you expect to be from the mean.
Which was the 3.3?
That was, yeah, the 3.3%.
So the total, yeah, okay.
So the highest take away the lowest. Whereas this was 0.8%, which is saying that on average, you expect to be within 0.8% away from the mean. Yeah, so in other words, in this range here. Okay, anything outside of that, we can start to say, are you a good hospital or bad hospital? Yeah. Now, one final thing that I do just want to introduce very, very quickly, this is standard deviation. Okay, this is basically what happens if you square it and then immediately square root it. Okay, but what happens if we don't do the square rooting step? Well, we give it a special name. We call it the variance. The variance, okay? So the variance is what happens just before you take the square root. So in other words, the variance would be either or this. Let me write this one over him. Okay, so the variance is essentially what happens just before you take the square root. Okay, so what you could say is that the variance, sorry, this should be squared. You could say that the variance is just the standard deviation squared. Okay, just the standard deviation squared. Okay, now can anybody think, just for 30 seconds, why are we interested in the value just before we take the square root? What does that tell us? What does that tell us? So why do we actually give this a special name? Just before we take the square root, we pause, we say that's the variance, then we take the square root, then it becomes the standard deviation. What does the variance tell us, which the standard deviation is harder to infer?
How different are they from the average? Like there are so many minuses and pluses. Like
No, necessarily, because remember we've squared it, so it's got to be positive. So actually plus or minus doesn't really come into it at this stage.
if it's above 1, maybe.
Right, tell me more.
So if it's below 1, it'll go lower.
Yeah.
If it's above 1, it'll go higher.
So are you trying to talk to me about outliers?
No, about like the value that you get.
It is to do with outliers though. Okay, so can I just take your attention for 30 seconds more, then we'll finish. Okay. This variance tells us information about outliers. Okay. Because if you think about it, just before we square root it, okay, because we've squared it, we've basically exemplified all of those distances. All those distances are going to be the square of what they were before. Does that make sense? Okay, so if I have a data set that looks like this, so let's suppose this is my mean, okay, and let's suppose we have lots of values quite close. So let's suppose that distance there is like 1, that distance there is like 2, that distance there is like 1, that distance there is like 3, okay? Then if we have a value all the way out here, in other words, an outlier, that's say 10 away from that, away from the mean line, okay? Would you be happy that because we're squaring it, these distances will still remain quite small? So when we square this distance, it's going to be 1, square this distance, it's going to be 4, square this distance, it's going to be 1, square this distance, it's going to be 9. It's fairly small distances, but then when we get here, when we square it, that distance becomes massive. It becomes 100. So in other words, what the variance tells us is whether there are any outliers in the data. In other words, if the variance is big, okay, so if the variance is really, really big, so much, much bigger than 0, then that gives an indication of whether there are any outliers in the data. Whereas if the variance is very, very small, okay, so much smaller, don't know how to write that, but if the variance is small, then it probably means that there are not many outliers. So the reason why we pause just before we take the square root and give it a special name, call it the variance, is because it gives us an indication of whether there are any outliers in the data. So I'll write that again. So if the variance comes out as big, because if we have outliers, the distance is going to be exemplified, because we're squaring it, okay, then that means that there's probably going to be outliers in the data. Whereas if there wasn't, all of these numbers would be relatively small, hence the variance would be small, and so therefore there's probably not going to be outliers in the data. Okay? So the reason why we give it a special name, more than just we do, is because it actually tells us whether there are outliers lying in the data. Does that make sense to everyone?
When you say big, you mean how?
It's subjective, but yeah, if it's a really big number like 100 or 1,000 or 2,000 or something like that, it probably means that there's outliers in the data.